Hello and welcome to Unit 4.3, your digital notes. So just to do a little review, we covered slope um, last, and slope is the steepness of a line. We have positive, negative, undefined, and zero. And when we're given a graph, a line on a graph, we can calculate our slope by finding the rise over run. And we do that by following these step-by-step instructions. We find the two distinct points that are, they may be given to you, or we may have to find them on our own. And if you find them on your own, you want to find 2 points that cross a crosshair right on the dot so the number does not have a decimal. So then, after we found our two distinct points, we're going to start with the point farthest to the left, which on this one would be right here. And we start counting our rise. And we either will go up or down depending on where our second point is. On this example, we count up 9 units. And so that is our rise. So down here you can see this is plus 9 because we're going up. If we went down 9, it would be minus 9. And now we need to calculate our run. And our run is our left or right. If we go right, it's positive. If we go left, it's negative. And on this one, we're going right plus 5 to get to our next point. So our slope for this line is m. Remember, m is the notation for slope, is positive 5, or I'm sorry, positive 9 over positive 5, which is 9 over 5. So there, we just found the slope for that line. Next, we looked at how to find slope using just two sets of coordinates for 2 points. And here, this is where we use our change in y over our change in x. So we literally subtract the y coordinates, and then we literally subtract the x coordinates and put them here, and that's going to be our slope. To do that, this is what it looks like. We have our 2 points given right here. We label them X and Y. That's very important. Then we find the change in Y. So we're going to use this point first for all of our equations. So here is our first Y. So our first Y is we're going to pull that down here. And our second y, we're going to pull that down here. And 8 minus 16 is negative 8. So this is where we get our negative 8. And then our change in x. So our change in x is our first x is right here. Our second x is right here. So 20 minus 9 equals 11. And our change in x is 11. And so we have a negative 8 over 11, which turns into just negative 8 over 11. You have color-coded steps um, to find the slope from coordinates and from a graph on your 4.2 notes. So make sure you have those handy if you need them. So today we're going to start with looking at slope with perpendicular and parallel lines. So we've talked about perpendicular and parallel lines several times. Parallel lines are lines that never intersect each other. So you're going to think of railroad tracks if you need a visual. Those two railroad tracks never intersect. They just run alongside each other. Perpendicular lines do intersect. They intersect each other at one time, at one point, and they form 4 right angles where they intersect. So you think of the crossbars right here on this kite. They come together to form perpendicular angles. And all of the angles formed by perpendicular lines are 90-degree right angles. So, how is slope related to parallel lines and perpendicular lines? Well, we recall that slope is the steepness of a line, and parallel and perpendicular lines have special relationships when it comes to slope. You can identify whether lines are parallel, perpendicular, or neither based on their slope. I know, we're going to look at it. So parallel lines have the same steepness, so they will have the exact same slope. Perpendicular lines do not have the same slope, but they do have a relationship, and we're going to look at that on the next slide. So it's important to know the difference in symbols and relationships with slope, and be able to give examples of parallel versus perpendicular lines. So parallel lines, let's look at these purple boxes. The symbol for parallel lines is you have the name of each line. So in this one, we're given M and N. Got that from over here. So, and then we're going to use these two. It's like kind of like an equal sign turned on its side to say that they're parallel. So two bars like that say that this means parallel. So parallel lines have the exact same slope. So if we were to find the slope of the two lines, their slopes would be the exact same number. So if one slope was -5, the other slope is -5, they are parallel lines. If they're 0 and 0, they're still parallel lines. If they're -1/6 and -1/6, they're parallel lines. So perpendicular lines, on the other hand, we're going to be the ones that come together, that cross each other at one point, one time, and they form 90-degree angles. You write perpendicular as C, because we have our C and D here, with this upside down T, capital T. So this says C, line C, is perpendicular to D. So the symbol for perpendicular is an upside down capital T. And perpendicular lines have opposite reciprocal slopes. I know these are words that are like, excuse me, but it's super simple to look at. An opposite reciprocal basically means that you flip the fraction over and change the sign. So a helpful tip is that a whole number can be changed by a fraction into a fraction by putting it over 1. So let me change color here. So here we go. We have 5, -5. You can change that to 5/1. You have 6 down here. This can be 6/1. So, okay, so now we have our fractions. Now we need to flip it. So the 5's on the top here, 5's going to be on the bottom over here, and change the sign. So this one's negative, so this one's going to be positive. Let's look at this 2/3. To get the opposite reciprocal, we flip it. The 3 goes on top and the 2 goes on the bottom, and we change the sign. It becomes a negative. When we're looking at a line that has 0 slope, its opposite is always going to be undefined. And our last one, we have 6. So its opposite reciprocal, we're going to put that 6/1. The opposite reciprocal, we're going to flip it and make it 1/6. And we're going to make it negative. Because this was positive, so this one has to be negative. So here's some examples. So for each problem below, we're going to find the slope of a line parallel to line 1 and the slope of a line perpendicular to line 1. So If parallel lines have the same slope, the slope for line 2, the slope that's going to be parallel to line 1 is going to be -4/5, because this tells us that our slope is -4/5. Parallel lines have the same slope, so it's the same. Perpendicular lines have the opposite reciprocal slopes. So a slope perpendicular to line 1, remember, we're going to flip it and change the sign. So we're going to flip it. The 5 is going to go on the top and the 4 is going to go on the bottom. And we're going to change the sign. So the original one was negative, and so this one's going to be positive. So line 2, or number 2, says line 1 has a slope of 7. So if it's a slope of 7, what is the slope that's going to be parallel to line 1? It's going to be 7. So if we want to find the perpendicular line that has the slope of line 1, it tells us that our slope is 7. So remember, if our slope is 7, that's like saying 7/1. So we're going to flip it and change the sign. Well, it's a positive 7/1, so we're going to get a -1/7. We flip the fraction and change the sign. So if it's positive, it goes to negative. If it's negative, it goes to positive. So here we have some more examples. So on this number 1, it says line 1 has a slope of 1/4. Parallel lines have the same slope. So slope parallel to line 1 is going to be, you got it, 1/4. Perpendicular lines have opposite reciprocal slopes. So the slope that's perpendicular to line 1, we're going to flip the fraction and change the sign. So our original fraction is 1/4. So we're going to get 4/1 and make it a negative. Well, if we have a -4/1, that's like just saying -4. So if we can reduce our fractions, we're going to reduce them, okay, guys? So number 2 says line 1 has a slope of 0. Well, parallel lines have the same slope, so the slope that's parallel to line 1 is going to be 0. And then perpendicular lines have opposite reciprocal slopes. So if we have slope equals to 0, then that's going to be like saying 0/1. So the slope that's perpendicular to line 1 is going to be 1/0, and that's going to be undefined, because remember we talked about if you have a fraction and you have 0 on the top or the bottom, that you can't do that. So it's going to be undefined. So on this one, you're going to work on your own. You have these little red ovals over here, and you're going to decide on these 6 problems if the lines are parallel, perpendicular, or neither. So look at number 1. It has the slopes of 2 and 2. Does that make those lines parallel, perpendicular, or neither? Number 2 has slopes of -4 and 7. Are those lines parallel, perpendicular, or neither? 3 has the slopes of 6 and 1/6, or 1/6. So are those parallel, perpendicular, or neither? 4 has the slope of -1/5 and 5. So are those parallel, perpendicular, or neither? 5 has slopes of 3 and 3. So are those lines parallel, perpendicular, or neither? And 6 has the slopes of 4 over 3 and negative 3 over 4. Are those parallel, perpendicular, or neither? So go ahead and just drag your oval to mark whichever one, circle whichever one you want to choose. When you're done with that, come back here. So, will you always be given the slopes to compare? No. Sorry, guys. Sometimes you'll just be given two sets of coordinates, then asked to determine if the lines that go through them are parallel, perpendicular, or neither. So you're going to have to find the slopes to determine the answers. So again, I've given you step-by-step directions here. And so we're going to have to figure out if these are parallel, perpendicular, or neither. But our first step we need to know is the slope for each line. Oh, pardon me. So just like we did previously, we need to start our step-by-step. So we need to mark our X's and our Y's for our lines here. X. Okay, so I've marked our X's and our Y's. So our next step is going to be, we need to solve for the change in Y. So our change in Y is 8 minus negative 4. And when you minus a negative, it's like adding. So you're going to 8 plus 4 is 12. And our change in X is going to be negative 6 minus negative 2. So when you subtract a negative, it's like adding. So negative 6 plus 2 is going to be negative 4. So our fraction that we got is 12 over negative 4, which we can reduce that because both of those numbers are divisible by 4, and we would get 3 over negative, or 3 over negative 1, and that turns to negative 3. So here's our slope for our first line is negative 3. Now we need to, our second step is determine the slope of the second line. So we've got our X's and Y's marked. We're going to pull our change in Y. So our change in Y, our first Y is 25, our second Y is 13. So 25 minus 13 is 12. Now we need to find our change in X. Our change in X is, our first X is 11, and our second X is 15. So 11 minus 15 is negative 4. So we get 12 over negative 4, which we can reduce to 3 over negative 1, which turns into just negative 3. So now we need to decide our third step, are the slopes equal? If they are, the lines are parallel. Well, is negative 3 equal to negative 3? They sure are. If they were not equal, we would ask ourselves the second question. Are they opposite reciprocals? If they are, the lines would be perpendicular. And if you answer no to 3 and 4, they're neither parallel or perpendicular. But this one, they are parallel because they have equal slopes. Let's look at a couple more. So determine whether each set of lines is parallel, perpendicular, or neither. We're going to use the color-coded steps as a guide to figure these out. So, number 1, we have line 1 and line 2. And our first step is always going to be to determine the slope of the first line. Well, we remember our our steps to finding slope given coordinates. So we have to find the change in y and solve for that. So our change in y for line 1 is going to be 2 minus 0 equals 2. And the change in x is negative 3 minus 7, which is negative 10. So our slope is going to be 2 over negative 10, and we can reduce that to 1 or negative 1 over 5. If you have a negative here or negative here on your fraction, it's going to make the whole thing negative. So, okay, we found our slope for line 1. Now we need to find the slope for line 2. So we need to find our change in y, which is 7 minus 13. And remember, when you subtract a negative, it's like adding. So that gives us 20. And then we need to find the change in x. So our x is negative 8 minus negative 4. And so remember, if we're subtracting a negative, it's like adding. So we have 8 plus 4 gives us negative 4. And that gives us 20 over negative 4, or negative, when we reduce this, it will give us negative 5. So now we found that the slope for both of these lines. So number 3, are the slopes equal? If yes, they're parallel. Well, no, these slopes aren't equal. So these lines aren't parallel. We move on to our second question. Are the slopes two opposite reciprocals? If yes, then they're perpendicular. Well, no, these aren't opposite reciprocals because they would have opposite signs. And they have the same sign. So they're not opposite reciprocals. So 5, did you answer no to steps 3 and 4? Sure did. So they are neither. These lines are neither parallel nor perpendicular. Let's look at number 2. We have line A and line B. So our first step up here is going to be to determine the slope of the first line. So to determine the slope of the first line, we have to find the change in y over the change in x. And we have negative 6, because here's our first y, and our negative 7, which is our second y. So negative 6 minus negative 7 is 1. Now we need to find our change in x. Here's our first x, negative 12, minus our second x, negative 4. Here we go. So that gives us negative 8. So our slope equals 1 over negative 8, or just negative 1 over 8. Well, we found that slope. Now we need to find the slope for line B. So we found our change in y over our change in x. So our change in y is our y's are 4 and negative 20. So 4 minus negative 20 is like adding 20. So we get 24 as for our change in y. And our change in x is 11 minus 8. And so 11 minus 8 is 3. So our slope gives us our change in y over our change in x is 24 over 3. Well, that can be reduced. 3 goes into 24 8 times. So there's our slope for here. So we found our slope for both lines. We have negative 1 over 8, and then we have 8. So are the slopes equal? Number 3, are the slopes equal? No, the slopes are not equal. So they're not parallel. Are the slopes two opposite reciprocals? Yes, they are, because this could be seen as 8 over 1. And so this would be the opposite reciprocal because we would flip it and change the sign. So yes, they're opposite reciprocals. So the lines would be perpendicular. So here, you're going to use the two lines for each of these problems, and you're going to find the slope of each of the lines, and then, drag and drop the words over here that complete each problem. So if they're going to be, you have the option of them to be parallel, perpendicular, or neither on either one of these. So remember, your first step is to find your slope for line 1, then find your slope for line 2. Then you're going to see if those are the same slope, opposite reciprocal slopes, or neither. So if they have the same slope, they're going to be parallel. If they have opposite reciprocal slopes, they're going to be perpendicular. And if they are neither, then they're neither. For your next one, activity, you're going to determine whether each set of lines is parallel, perpendicular, or neither. So some of these, it gives you the slope. Some of them, it gives you the points, and you're going to have to find the slope of each line and then decide whether they're parallel, perpendicular, or neither. So when you find, here are your answers to choose from. You have parallel, perpendicular, or neither. On here, this first set, they give you the slope. So is it the same number? Then they're parallel. Are they opposite reciprocals? Then they're perpendicular. Are they neither? Then they're neither. Simple as that. So once you decide on your answer, you're going to come over here, you're going to cut and paste and put it in the correct answer square. So you're going to need some pencil and paper, guys, to solve for your slope. So on this side, you're going to remember to solve slope given 2 points. These are the steps that you take. Label the x and y coordinates of each point. Subtract your y coordinates to get the change in y. Subtract your x coordinates to get the change in x. And write your y over your change in y over your change in x. And if you can reduce the fraction, reduce it if possible. So this slide is in the steps to find slope given 2 coordinates is in unit 4.2 digital notes. It's slide 10. You have this. So work through these. You have 1, 2, 3 slides that need to be filled out on these notes. So go ahead and get that done today. If you have any questions, please reach out. I'll be here, and I hope you have a great day.